When it's time to sense the enriched strips and they're showing up across the field, this is going to be a little tutorial about how we need to go out there, run the GreenSeeker sensor, and then enter that data online to get your nitrogen rate recommendation. The new handheld is quite easy to use. It's easy to hold, very ergonomic, it stays flat. We want to make sure that it's pointing down towards the ground as we're walking. On height over the crop, we want it about 3 feet above the crop, which on a normal person is going to be about waist high. As we're walking through the enriched strip, we pull this button and hold down until we're at the end of the strip. Release, a number will present on the screen. We need to have a pencil, pen, or a piece of paper with us so that we can write this number down. This number will only be shown for about 3 seconds, so we need to make sure that when we release, we get a good look at that number and write it down as soon as possible. Now we're going to come back across from the enriched strip, maybe 10, 15, 20 feet away from it, walking back down the farmer practice, again, pulling the trigger, not releasing until you're into your pace. I usually like for folks to walk around 100 paces through both the strip and the farmer practice to get a good average number. Now we'll want to go around bad areas. If it's the top of a terrace or a salt spot or a dry spot, try to avoid those bad areas that don't represent the field completely. Once again, we'll need both of those numbers from the enriched strip and the farmer practice to go into that online calculator to enter the data so that we can get a nitrogen rate for that field. Now once we have the data and we're ready to go in, this can be on your desktop, laptop, iPad, it can be on a cell phone or any of those things. There are 3 important pieces of information that have to be entered and can't really change. 2 are the NDVIs, the farmer practice and the enriched strip, and then planting date, which is very important. To get to the calculator, you could either Google NUE, it's going to be one of the top ones, or just go straight to the website, nue.okstate.edu. It's brought up here on my iPad. Once you get to the website, let's go to NUE Tools. There's the old calculator, that's a Texas Instrument calculator. We go through there. Now, in this, we have a very large drop-down menu of options. Currently, there's 31 options on this site. For most of everybody that's going to be using this technology, we're wanting to go to winter wheat, U.S. grain belt only. It's the #1 option. Once you get to the online calculator, we go in there, you'll see the page. We have an input section and also an output section. Scroll to the bottom of the page. If you are in the state of Oklahoma, you want to choose the button within Oklahoma. This allows us to access the mesonet sites, which gives us a reading of temperature and growing degree days, which is very important in the calculation of the nitrogen rate. That's also where your planting date comes into impact. So now, as you see the screen, we're now within Oklahoma for the winter wheat option #1. We'll go in, enter planting date. In this case, I'm just going to use September 1st. For the day of sensing, it needs to be prior to sensing. So let's say you sensed on February 15th. Since Mesonet has not compiled the data for February 15th as of yet, you'll need to actually enter February 14th for the date. Today's date's the 10th, so I'm going to enter the 9th so that we have that data set. The next part is choosing the Mesonet site closest to the field that you're using. Here in Stillwater, we have the Stillwater location, the Mesonet just right outside of town. So on my iPad, I have to scroll down to the Stillwater Mesonet site, choose Stillwater, and now it's time to enter the 2 NDVI readings that you recorded earlier in the field. The farmer practice, the area outside that enriched strip, is the first one to enter. We're going to put some values in. I want to choose a 0.5. Usually the sensor will give you 2 to 3 decimal places. 2 is the most important. You go to 2 decimal place and it'll be good. Secondly, we enter the enriched strip value. Then we have a maximum yield option for the calculator. In this option, we're just wanting to create a table where we cannot go above something that's just not possible. Usually we use a 2 times average yield or 2 times maximum yield. So in the Stillwater region, I want to use about 100 bushel per acre max yield, just because the potential for the site I'm at will not hit 100 bushel. It just does not have the soil type or environment. Next, we have the expected grain price and fertilizer cost options that we put into this. These numbers need to be filled out, but they do not make a difference on the nitrogen rate that's recommended. It's just something that you can use to evaluate whether or not you want to apply fertilizer, if it's economical and practical. So in this case, we're going to put an expected grain price in of $6, expected fertilizer price of 60 cents per pound of N, so that's dollars per pound. So we'll go in here and 0.6. And at this point, we have all the inputs entered into the calculator. We have planting date, sensing date, the 2 NDVI values, a max yield, and then the expected grain price and expected fertilizer price. With that, we submit. Wait for it to look up on the calculator. And this will give us our outputs. This is a common error you'll see when you're running in the springtime. It's January. I have not figured out that it's 2014 yet. So in this case, this is a good error here that you see a critical error. I was out of database because I actually put January of 2013 as a sensing date. So I'll go back in there, correct that, and make it January 2014. Make sure all my values are still correct in there. Everything is as I entered. Hit submit form one more time. When we look at the outputs, the first output on there is response index. In this case, RI is 1.33, suggesting that if we apply nitrogen fertilizer, we will increase yield by about 33%. The next is days, GDD greater than 0. This says that we've had 94 days that winter wheat could have grown since it was planted. YP0, or yield potential without fertilizer, in this case is 35 bushel. Yield potential if we do fertilize is 46 bushel. The cumulative GDD is a value that we use for summer crops and winter canola. For winter wheat, it's not particularly important. N rate recommended in this example is 33 pounds of nitrogen. See that I do round it up. This is a very accurate estimator, but in most applications I'd suggest apply between 30 and 35 pounds will get you a good recommendation. Gross return without added fertilizer, $208, and gross return with fertilizer is $256. So that means we have a potential to increase economic per acre about $50. If you are in the NRCS EQIP contracts, you can go through this output, you submit and hit print, and this will give you a printout for your local NRCS office to document the values and the rate recommended. If you have any questions, please feel free to contact me or look at the website nue.okstate.edu or my website npk.okstate.edu.